Hello everyone, this is Mr. Anziano again, here this time with pages 3 and 4 of the Unit 5 test review. Although you already have the answers posted on Google Classroom, hopefully you find this video helpful in understanding the problems just a little bit more. So I'm going to go over page 3 first, starting with number 14. Here they're giving us the graph of an exponential function, f of x. Here's the equation. F of x is equal to a times b to the negative x plus c. And here's the graph. Okay, the function is pictured over here to the right. It says, is the value of a times c positive or negative? Okay, we haven't really seen a question like this quite yet. So really all we need to know, if it's positive or negative, right, then we're looking for the sign situation. Is it going to be a positive times a negative times a negative, a positive times a positive, and that will tell me what the sign is of a times c, right? So we know from the graph that c is actually, isn't that just the same as the horizontal asymptote? Which happens at y equals -1. So we know c equals -1, and we know a is negative because the graph is underneath or below the horizontal asymptote. So the fact that a is negative or less than 0 and c is negative because it's -1 means that really a times c is actually a negative times a negative, which will result in a positive. Right? So the answer for number 14 was positive for that reason. Okay. Number 15 is asking us to identify the range. It's a multiple choice, asking us to identify the range of the given exponential function. Okay, now it also says, here's a hint, sketch a quick graph. Right, so for my quick graph, I like to consider what the graph would have done if there weren't any reflections happening. So if I look at the exponent, I notice that it's positive, so that means that there's no y-axis reflection. But I do see a negative coefficient, a negative a value, so I know that there will have been an x-axis reflection. I also know that the horizontal asymptote is at +1, and I know that if I set the exponent equal to 0, I'm actually going to get a shift of -2, so 2 units to the left. So let's say that's -2 right there. Okay, so that's kind of like my new x and y axis in a way. So with that information, guys, I can kind of think about what was happening originally, right? Before I had the x-axis reflection, this was going to be exponential decay because b, or 2/3, is actually a fraction, right? If b is between 0 and 1, then the graph models exponential decay. So it was going to look something like this. Okay. That's what the parent function would have looked like, but because we have an x-axis reflection, I know that my true graph is actually going to look something like this, with a solid line. Okay. Now, if my graph is doing that, if that's what the final product is going to do, that means that the y values are actually going to keep going down this way, right? And they're going to come up here, and they're eventually going to hit that horizontal asymptote. Well, they're actually not going to hit it. They're going to come really, really close to it, but they will never actually cross the line y equals 1, which tells me that the range is from -infinity to +1. Okay, and that's actually option B. Okay. Looking at 16, they're asking us to complete the table without using a calculator, which should be easy enough because we're bright young mathematicians and we know how to plug stuff in, right? So when x is 0, let's see what happens to g of x. Plug in 0 up here for x, and we get 2 to the -0 plus 3. Well, -0 is the same as +0. It's just 0, and 0 plus 3 is 3. So really that's 2 cubed plus 1. What's 2 cubed? It's 8. 2 cubed plus 1 is the same as 8 plus 1, which is 9. All right, let's plug in 1 now. We get 2 to the -1 plus 3, and -1 plus 3 is actually 2. So really that's 2 to the power of 2 plus 1, and 2 squared is 4. 4 plus 1 is 5. So you should be at a point where you can kind of do these in your head, and if you can't, well, you can write some quick notes out. All right, don't worry too much if you can't see all that happening in your head. Just for the sake of time, if you can do it in your head, it's going to save you some time when it comes to it. All right, let's plug in 2. If we plug in 2, we get 2 to the power of -2 plus 3. Well, -2 plus 3 is +1. 2 to the positive 1 is 2, and 2 plus 1 is 3. Okay, next we have to plug in 3. If we plug in 3, we get negative 3 here, plus 3, which is 0. 2 to the 0 is 1, because anything to the 0 is 1, and 1 plus 1 is 2. All right, and when we plug in 4, we actually get negative 4 here plus 3, which is negative 1. 2 to the negative 1 is actually 1 over 2 to the positive 1, right? So we have 1 over 2 plus 1. Well, 1 over 2 is just 1/2, or 0.5, okay? And 0.5 plus 1 is 1.5, or 3/2, however you want to think about that one. Okay, so there's your table without using a calculator. Next, it says, what is the equation of the horizontal asymptote of the exponential function f of x equals negative 4 minus 2 to the x plus 2 power? I personally like to rewrite these to where I have f of x equals negative 2 to the x plus 2, and then I put that constant term at the end, so it looks a little bit more familiar. So there we have negative 2 to the x plus 2 minus 4, and it should make it a little bit more obvious what our horizontal asymptote is. Remember, it's just the value of the constant, so really y equals negative 4 is the equation of the horizontal asymptote, and that is letter A. Okay. And lastly, number 18 here, we have an equation to solve. Now, guys, whenever you have to solve an exponential equation, my best recommendation would be to first determine what the base needs to be. What number can I raise every number that's already in the equation to some power of to make all of those bases be the same thing? In other words, is there some smaller number that I can use to rewrite 4 as a power, 32 as a power, and 1/4 as a power? If you guessed 2, you'd be correct. We're going to use the base 2. So first, we rewrite 4 as 2 squared to the x minus 2, times 32 is actually 2 to the 5th to the x plus 2, and that's going to be equal to 2 to the negative 2. Remember that fraction right there, 1/4? That one's a little tricky, but 1/4 really just turns into 2 to the negative 2 power. And we're raising that to the x minus 2 on the outside there. Okay, so really distribute the 2 in this first term into both of the x and the minus 2 terms, right? And we end up getting 2 to the 2x minus 4 times 2 to the 5x plus 10 is equal to 2 to the negative 2x plus 4. Okay, and because this is 2 to some power times 2 to another power, all we're doing is adding the exponents together. So really this is going to turn into 2 to the 7x plus 6 is equal to 2 to the negative 2x plus 4. And now we have the same base on both sides of an equation. So all we need to do is set the exponents equal, and we end up getting a simple multi-step equation, multi-step linear equation, where we set 7x plus 6 equal to negative 2x plus 4. Combine like terms, I'm going to add the 2x over to this other side, so I get 9x equals, and I'm also going to subtract 6 from this side, so I get negative 2. Dividing both sides by 9 gets us x equals negative 2/9. All right, and is that one of the options? Oh, we're off the screen a little bit. Negative 2/9 is letter D. And with that, I'm going to pause as we transition into page 4. All right, so here's page 4. I went ahead and highlighted 10 of these problems, and I only have about 6 minutes left on this video. So I'm going to try and move quickly, and I might pause, so forgive me if it feels a little abrupt between problems. But I'm going to start with number 19 here. Okay, so number 19, we have some big expression, and it's all raised to the power of 4. Okay, so I'm going to kind of take it one term at a time. I know, first of all, that x to the 0 to the negative 1, well, that's just x to the 0, which is 1, to the negative 1, which is still 1. So really, in my numerator, I have 1. Okay. Now, I also know in my denominator here, I'm going to have a constant of 2. I'm going to have an x with a power of 4 because that's x to the 1 and that's x to the third. So really that's going to become 2x to the fourth. And then what's going on with the y's? Well, guys, this is y to the negative 1 times y to the positive 1. Multiplying those two things together, we actually end up essentially canceling one another out, because what you're going to have is y over y, which means that really those two things cancel one another entirely. Or if you think about it like multiplying y to the negative 1 and y to the positive 1, adding the exponents, we get y to the 0, right? So really, that is what we have left. Okay, so if I take this whole thing and raise it to the power of 4, I'm going to be left with 1 to the fourth is still 1 over 2 to the fourth is 16, and x to the fourth raised to the power of 4 is actually x to the power of 16. Okay, and that's the answer for number 19. Okay, next we're going to look at 21. And 21 is actually really tricky, yet deceiving at the same time, because it's this entire mess, but guys, it is all raised to the power of 0. So what is it? Ha! It's 1. I spent about 5 minutes doing that last night and got a different answer, then realized that it was raised to the power of 0. So don't make the same mistake I did, and look at your exponent before you begin the problem. So looking at number 22 next. We have a bunch of stuff. Again, we need to figure out how this is going to cancel, what's going to happen with the exponents. So if I start by looking at the constants, I actually see that I'm going to have a 2, and then I notice right away that x to the fourth combined with x to the negative 3, again, add the exponents, or in this case subtract them, and we just get x to the 1. So I have 2x, and then I also have a y right there, so I'm just going to leave that alone and put next to it this 2x cubed thing that's going on here, except y to the 0 is just 1, so I can ignore that. We're going to raise that to the power of 2. Okay. Next, we get, well, actually, it turns out that y to the negative 2 is going to go up here into the numerator, isn't it? So really, we have a y squared on the outside as well. Okay, and x to the 0, I don't even have a denominator because x to the 0 is just 1. So really, what does this turn into? Well, all we need to do is distribute this exponent of 2 into the 2, the x, and the x cubed, and we end up with 2xy times 4x to the 6th times y squared, and we combine everything in the end, and we get 8x to the 7th, and then y to the 3rd. Okay, so 8x to the 7th, y cubed. Next, we're going to look at 23. All we need to do is rewrite that, so we end up with 10p in parentheses. Remember, the index of the radical expression actually becomes the denominator of the exponent, so we have a denominator of 6 and a power, oh, there go the lights, a power of 5. Okay, and next we're going to look at 26. N to the power of 5 over 4, well, the denominator of that rational exponent becomes the index of the radical expression, and really the only thing we have there is n. There's nothing else surrounding it, so that's just going to be an n on the inside, and we're going to take that whole thing and raise it up to the power of 5. That's how we rewrite the exponential expression in radical form. Okay, and then we got 28 and 30 of this next section. First thing I'm going to do is rewrite this as the cube root of 125 x to the 6th. And really that whole thing, I guess technically we could do this, take it up to the power of 1. Don't really need to, but we can. What is the cube root of 125? Hopefully you said 5. What is the cubed root of x to the 6th? Hopefully you said x squared. Right, and that's our answer. 5x squared. Number 30, same thing, except this time I'm going to rewrite this as the fourth root of x to the 8th. We're going to take that whole thing and raise it up to the power of 5. That's how we rework those exponents. Okay. Now the fourth root of x to the 8th is actually x squared, and we're going to take that and raise it to the 5th, which really means we multiply the exponents together and we get x to the 10th. Okay. Now I'm going to pause and I'm actually going to make another quick, like 4-minute video because I'm running out of time here for numbers 32, 38, and 41. So that will follow immediately.